Hello everyone and welcome back to the last video of this particular module called as functions. Now in this particular video, I'm just going to tell you how to basically go about in developing couple of programs in C which makes use of recursion. Probably we'll have a look at three programs, out of which the first one is binary to decimal conversion using recursion. I've already written a program. I'll just explain you and also help you in tracing the program. And then as usual, we are going to transfer this code in the online compiler and see whether it works or not. So I have my user defined function called as bin to decimal, right, which takes one parameter. Uh, the data type of that particular parameter is long, just to ensure that if I'll end up giving a bigger binary number, I should get its equivalent decimal. Okay, so this is the logic behind it. And then let me come back to the main program. In the main program, I have a variable declared as n, and then I'm entering a number, and the format specification for long is %LD, and then I'm trying to print the binary to decimal by calling a function here, right? Now from here, whatever the value of n you enter, the control from here will go to the function definition part, and if you look closely, if you observe, this is the place where I am calling the recursion, right? So the red color highlighted one is the place where I am calling the recursion. Now let us try to trace the program. Let us say I have the value of n as 1010. Okay, so I have the value of n as 1010. That's the binary one. So you're calling the function with 1010 as a parameter. So the value of num also becomes 1010. So that is what I have highlighted here. It becomes 1010. And then what happens is now I have my if condition, if num by 10, right? So num by 10 is nothing but 101, correct, which is true. Num by 10 is 101. See, 1010 divided by 10 is 101. It becomes true, and my not of true, right? So this becomes true. My not of true is actually false. So when it is false, this particular condition will not be executed. Control will come and it will execute this particular condition. Now, what is this particular statement? This statement is return num percentage 10. So what is num? Num is 1010, correct? Its percentage 10 is 0. So this is what it is, right? So that is my num percentage 10 is 0 plus bin to decimal of num by 10 into 2. So my num is 1010. 1010 divided by 10 multiplied by 2. So that is 201 multiplied by 2, that is 202. So here, after the first call, you are again calling a function, the same function, which is recursive in nature, with 202 as a parameter. Remember, the first time when you called the function, you called with 1010 as a parameter, and now you are calling the function with 202 as a parameter. So my num will become now 202, right? And then num by 10, so I'll just continue the same procedure. Num by 10 is 20. 20 is true, so not of true is false. And then what you're going to do, it is going to execute this particular statement. That means return num percentage 10. Now what is num percentage 10? That is 202 percentage 10 is 2. This 2, please understand, right? Now this 0 is the one that is coming from the previous statement. So this is already there. So this portion is going to come from in the second step. So return num percentage 10 plus. So that is num percentage 10 is 2 plus binary to decimal of num by 10 multiplied by 2. So your num is 202. So 202 divided by 10 multiplied by 2 will give me 40. So now I am going to call the recursive function with 40 as a parameter. My num becomes 40. Then my num by 10, that is 40 by 10 becomes 4, which is true. And then this particular statement, not of true, is actually false. So once it is false, it will come and execute this particular statement. So that is, this already I have from the previous one, 0 plus 2. Now it is num percentage 10. My num is actually 40. 40 percentage 10 is 0, and then you are calling the function binary to decimal with num by 10 multiplied by 2. So num is 40, so 40 by 10 multiplied by 2 will give me 8. So now I am going to call a function with 8 as a parameter, right? So my num becomes 8. Now once my num becomes 8, 8 by 10 becomes 0. 8 by 10 becomes 0, which is false. Now not of false becomes true. So my if condition becomes true. And now what happens? For the first time, this particular statement will be executed because the if condition is true. Now what is this statement? Return num. So my num is 8. So it will return 8 in place of this, right? It will return 8 in place of this. And then I have that 8 here, right? Now already I have this 0 plus 2 plus 0 coming from the previous steps. So now what happens? 0 plus 2 plus 0 plus 8 is equal to 10, right? So return will return the value as 10. It will come and sit in this particular place, right? In this particular place, and then it will give the answer as binary to decimal is equal to, right, 10. So decimal equivalent of 1010 is 10, right? So you know very well that 1010 binary is nothing but 10 decimal. So what I'll do is I'll just copy and paste this particular program in my online compiler, which I've already kept ready for you, right? And then let us see how it works. So this is the program that is there in front of you. Let me compile and run the program. So here it is. Enter a binary number. So I'll just say 1010. That's the number we had given as input during our tracing. So binary to decimal is equal to 10, right? So let me run the program with a little bit better. This one, what I can say is I can just add binary of percentage LD is, or I can put it like this, percentage LD binary is decimal LD. So, and I can just say here n comma, okay, I'm sorry, n comma, right? So let me run the program now. Enter a binary number. So I just say 1010 and it will give me 1010 binary is decimal 10, right? So that's how the program works. Let us also run for one more input. I'll just give 1101. So how much it is? 8 plus 4, 12 plus 1, 13. So 1101 binary is decimal 13, right? So that's how the program actually works. So only thing that you need to also keep in mind is this particular line, that is line number 5, is executed only once, right? And that too at the last step of your entire recursion process, that too when this particular condition becomes false, right? So num by 10 should become false and not of false will become true, and then your entire if condition becomes true. That is where line number 5 gets executed. So this is how you basically land up doing the program for binary to decimal conversion. Let us look at one more program. I'm not going to give you much explanation about it. GCD of two numbers using recursion. So let me just, now this is a program for you. I'm just trying to find the GCD of two numbers, right? So let me copy this for you. Okay, so I have my user-defined function called as find GCD, which takes two parameters. Both are integer data type. Line number 3 is my declaration statement, and line number 9 I'm trying to call the function. So this is where is my function call, and from line number 13 onwards is where is my function definition. And line number 15 and line number 17, these are the two places where I'm performing my recursion. So if you look at this particular function definition very closely, you will see the change in the parameter, right? So in line number 15, the first parameter is x minus y, and the second parameter is y. But in line number 17, the first parameter is x and the second parameter is y minus x, right? So let us run the program. So it's giving an error. Okay, that's nice. All right. So it's just asking me enter two numbers to find GCD. I'll say 12 and 30, sorry, 12 and 36. And then it says the GCD of 12 and 36 is 12, right? So I don't need to tell you what do you mean by GCD of two numbers. You would have done it quite n number of times before you came to engineering. Let me once again run the program, and then this time I will say what 5 and 17, and then it says GCD of 5 and 17 is 1. So that's the program for you, GCD of two numbers using recursion. Let me also give you the last program on recursion before I wind out this particular module, that is called as sum of first n natural numbers using recursion. Sum of n natural numbers using recursion. So that's the program in front of you. So I'll just copy it. Okay, so that's the program. This is my function sum of natural, right? And this is where I am performing my recursion. So in this particular application, I need to call recursion only in one place, that is in line number 7. So how many terms you want to add? Let me say I want to add the first 5 terms, that is 1 plus 2 plus 3 plus 4 plus 5, and I get the answer as 15, because you know the sum of first 5 natural numbers is 15, 1, 5. Let me add now 9. Sum of first 9 natural numbers is 45, right? So that is how you basically go about in writing a recursive program to find the sum of first n natural numbers. So just a quick glance on this. You call the function with let us say 5 as a parameter. 5 gets here. Value of n is 5. 5 is equal to 0 is false. So it comes here. It is 5 plus 5 minus 1. So 4, right? So the first time when you are calling the function, you call with 5 as a parameter. Next time when line number 7 is invoked, you are calling the same function with 4 as a parameter. So that is a pure example of recursion. And subsequently, you call the same function with 3, 2, 1, like that. It is exactly how you have seen earlier, a factorial of a program, right, with the help of recursion. So that is the property of recursion, that every next step you should basically or slowly proceed towards the termination condition. And if you don't do that, you know what happens actually. Okay, so that is how the program on natural numbers is developed. So just have a quick glance on this particular program. It is there in front of you. Okay, so let me conclude this entire module on functions, right? So functions, and more functions, right? We have exposed ourselves to functions to a very large extent, try to understand how this particular topic or module or the concept in C language works. We exposed to the definition of functions, and we have seen some example where we started with you remember the girlfriend and bike getting punctured, all the way from there till the most important and very very important feature of C language, that is recursion, right? So functions are actually complete, independent, and they have their own variable declaration. They have their own statements, and obviously they have their own opening and closing curly braces, which we call it as begin and end, right? Now, function definition and declaration are different, right? So we have seen the three important components of functions, right? So you have function declaration, you have function definition, and you also have a function call. So if you look at the order of it, so you have declaration, then you have a call, and then you have a definition, right? So that also depends actually if you are trying to write the function definition first before main, or is it that you are writing the function definition after main. So as a programmer, you take a call, right? There's absolutely nothing very hidden agenda behind that, right? Then we have seen different types of storage classes, which has got its own unique presence in the programming language. Try to give us answers to a couple of questions which we had in mind right from day one, when I was not initializing anything to a particular variable, but still it was giving me the garbage value, right? So storage classes landed up answering quite good number of questions which you had in your mind. Then we moved on to the last topic, what is called as recursion, right? And you know the definition of recursion. I would not like to reiterate again, but let me tell you that it's an elegant programming technique. So having known all this, let me conclude in two lines, but that is what opens sealed doors and lets in more exciting vistas. That's what adds punch to the programming, putting so much power at your fingertips, providing answers to the questions you never asked, digging up roads you never thought could exist. Let us meet in next topic to explore what is called as pointers. Long awaited topic of mine, that is pointers.